Assalamualaikum and good day to everyone. Welcome back to the chapter 8 on the characteristics, processing, application of metals and alloys. Okay, for this time, you are going to learn about the part 3 of this chapter 8. This part 3 is about the fabrication process or techniques of metals and its alloys. Okay, metal fabrication techniques is a manufacturing process which is used to shape the metal into parts or end products. We use a number of techniques in order to shape a sheet metal into a final product. Most fabrication techniques uses sheet metal which can be up to 0.25 inches thick. The fabricators convert this sheet metal into products. They cut, stamp, fold, shape the metal in order to produce the desired product or the finished product. The process involves cutting, burning, welding, machining, forming, and assembly in order to get the final product. Okay, let's look at this one. This is an example of a simple product, which is a beverage can. Most of the beverage can was made of aluminum alloy. This can start with a single sheet of the aluminum alloy. Okay, where you can see here, this is a roll of aluminum alloy sheet. Okay, and then the process of making a beverage can is begin with a drawing process, followed by dome forming process, and then trimming process, cleaning process, decorating process, neck forming process, and the last process is plank forming process. Even though this beverage can is a simple product, but it still requires numbers of manufacturing processes. Okay, what are the examples of products that can be made using metal fabrication process? The products are hand tools, cans, pipes and pipe fitting, equipment attachment, bolts, nuts and screws, cutlery, metal windows and doors, and also car parts. Okay, this is the classification of metal fabrication techniques. Okay, these techniques of metal fabrication can be classified into three big groups. There are forming operations. Okay, the second one is casting, and the third one is miscellaneous testing. Okay, how to choose the best techniques for materials or metals? How to choose the best fabrication techniques for metals? Okay, for this forming operation techniques, okay, this is suitable to be used for making a product made of metal which can withstand a, a high external force, high mechanical or external force. Okay, while for this one, for this casting process, this process is suitable for making a product made of metal which is brittle, metal which cannot withstand a high external force. So the only method that we can use is by doing the casting process. Okay, under the forming process, there are 4 types of forming process. One is forging, rolling, extrusion, and drawing. And for this casting process, there are a few types of casting process. Okay, there are sand casting, die casting, investment casting, and continuous casting. Okay, for the miscellaneous, the types of techniques are powder metallurgy and welding. Okay, let's look at one by one. Let's look at the technique one by one. Okay, let's start with the metal forming process. In this process, the deformation of the metals is via external force. Meaning that external force is given to the metal in order to deform the metal. Okay, what are the tools normally used for this metal forming process? Okay, for the blacksmith, they use a simple hammer to fabricate the metals. Okay, this is hammer. We give a compressive stress, compressive force onto the metal sheet in order to fabricate the product. Okay, what else tools for this metal forming? Okay, in industry, they use rollers in order for bending the sheet metal. Okay, this is roller. Okay, and this guy holding a metal sheet. And then what else? In industry also, they use a die and punch in order to shape the metal. What is die and punch? Die is this part, the bottom plate. Die will have the shape of the final product that we want to produce. Okay, and the top here, the top part here is the punch. The compressive force will be applied to this punch in order to deform this metal. Okay, working processes, or we call it also as a metal forming process. Used to mechanically shape metals into other products form. And in this metal forming process or working process, there are 2 ways of performing this process. One is hot working. Second one is cold working. Okay, for the hot working process, we give heat. We heat the sample. Okay, the temperature during the process is in the range of 0.6 to 0.8 of the melting temperature for the metal. While for the cold working process, the temperature during the process is less than 0.3 of the melting temperature for the metal. Okay, for the definition, hot working process is the deformation under the conditions of temperature. Okay, where in this process, recrystallization process will occur simultaneously with the deformation. Recrystallization is the formation of new grains. If you still remember, in the annealing process, the knowledge in the previous part 2, during the annealing process, annealing is a heat treatment process for steel. So one of the phase in the annealing process is this crystallization process. Okay, during this phase, new grains will be formed to replace the old grains of metal. Okay, what are the examples of hot working process? There are rolling, forging, and extrusion. Okay, for the cold working process, the deformation carried out under the condition where recovery processes are not effective. At the temperature which is less than 0.3 of the melting temperature. Okay, for the examples of the process are rolling, forging, extrusion, drawing, switching, and coining. Okay, let's look at the first technique under the forming process, forming metal process. Let's look at this one, forging. Forging is mechanically working or deforming a metal of hot or cold metal. The application of successive blows or continuous squeezing, which is a compressive force, via mold and die or high impact process. Okay, forging is the working of metal into a useful shape by hammering or pressing. Forging is where the metal is deformed due to the compressive and high impact forces. Okay, there are two types of forging. Forging can be done under a cold condition at room temperature or under hot condition. The examples of products that can make using this forging process are wrenches, automotive crankshaft, and pistons. These are the typical products from forging process. Okay, let's look at the comparison between the cold forging and the hot forging. Cold forging is a very conventional forging process. A simple forging process. This cold forging process is performed at room temperature. Okay, the job piece is compressed between two dies until it has assumed their shape. While for the hot forging, it is performed at extreme high temperature. Yeah? It depends on the melting temperature of the metals. Yeah? For steel, okay, the temperature for the hot forging process is at 1100 degrees C. For aluminum alloys, okay, the range of the temperature is from 360 to 520 degrees C. Okay, and for the copper alloys, the temperature range is from 700 to 800 degrees C. Okay, for the cold forging process, the deformation is below the recrystallization temperature, meaning that during this process, no heat is given to the process, is given to the material. Okay, and the deformation is small. Yeah? For this hot forging, the deformation temperature is high enough for the recrystallization to occur. Okay, from this recrystallization, it will form new grains. Okay, new grains. Okay, these new grains will have properties of low strength and also low hardness. It is because the temperature during the process has softened the metal. Okay, that's why the metal after the recrystallization occurs will have low strength and low hardness. Meaning that the metal is softened because of the temperature applied to the metal. So, because the metal is softened, so large deformation can be achieved. Okay. Okay. How about the advantages? Cold forming. The metal will have high strength. Okay. Very little or no finishing work. The end product is shiny. Smooth surface. Economical and high production rates. For the hot forging, the sample will have a good ductility. Low force is required. You just need to have a very small force in order to deform the metal during the hot forging process because the metal is softened due to the temperature. Okay, for the disadvantages for the cold working process, in order to deform the metal, we need to have a high force. And then only simple shapes in high volumes can be shaped. Low ductility and residual stress may occur due to the compressive force applied to the sample. For this hot forging, the advantages are low strength and will perform oxidized or rough surface because from the heating process, it will form an oxide layer on the surface of the metal products. Okay, this is the microstructure of forged articles, forged product, where you can see the grain flow. This grain flow follows the contour of the component, which often maximize strength in the direction of greatest operating stress. Okay, for this, we are still in the forging. Okay, we are still in the forging process. this forging process can be grouped into the shape, the variety of the die. Okay, the first one is closed die. What is the closed die forging? Closed die is the shaping of hot metals within the cavities or walls of two dies that come completely to enclose the workpiece. In the forging process, we need to have the top plate, we call it as a punch, and the bottom plate, we call it as a die. And this punch and die is following the final shape of the product. Okay, in this closed die forging process, the punch, the workpiece is laid at the center, in between punch and die, here, metal, and then we give a force where this punch, we give force onto this punch, where this punch will come together, will come closer to the die and completely compress the workpiece. And the workpiece will follow the shape of the die. Okay, as what you can see from this animation. Start with a metal block, put in the middle between the punch and die. We give a compressive force. Okay, so the metal will follow the shape of the die. Okay, how about the open die forging? Most forging processes begin with this open die forging. Okay, open die forging is hot, mechanical, forming between flat or shaped dies, in which the metal flow is not completely restricted. For this open die forging, we need to have a punch and flat anvil. Okay, this is the metal block. During this process, this flat metal punch will struck against the metal stock. And the flow of the metal, when we struck the metal, the flow of the metal is not restricted. It's not restricted. The metal can flow to the side of the to the both sides of the metal. Can freely flow without restricted by any walls of dies, as what you can see from these short videos. Okay, start with a hot metal block and punch will come closer to the die, and the restriction of the metal is not, the flow of the metal is not restricted by any dies wall. Okay, metal flow. Okay, the equipment for this open die forging may range from the anvil and hammer to a giant hydraulic presses. Okay, these are the examples of forged products. This is from hot forging process. Okay. Okay, this is also an example how the industries perform the open die hot forging process. Okay, the only moving plate is the punch. Okay, punch is moving, and also the metal is moving. Okay. Okay, next we move to rolling. Okay, what is rolling? Rolling is a process of reduction of the cross-sectional area or shaping a metal piece through the plastic deformation caused by a pair of rotating in opposite direction of metals roll. Okay, here is what you can see from the animation here. In this process, there are two rollers, okay, on the top and at the bottom. These rollers are rotating in the opposite direction. The metal will go through the roller. Okay, so please observe. Okay, how about the thickness? The thickness of the initial metal is bigger, is thicker than the after deformation. Okay, thickness before T dot. After go through these two rollers, the thickness is decreased to T1. Okay. Okay, this is the most widely used metal working process because it lends itself to the high production and close control of the final product. There are two ways of doing performing this rolling process. It can be performed under hot condition and also cold condition. Okay, hot rolling is the most common method of refining the cast structure of ingots and billet. Okay, cold rolling is most often a secondary forming process that used to make bar, sheet, strip, and foil. Okay, cold rolling is a rolling process at temperature that are close to the normal room temperature. Room temperature. Okay, cold rolling process involve no recrystallization process. So it require more energy in order to deform the metal. Okay, this will increase the strength of the finished product through the use of strain hardening process. If you still remember in the part 2 of this chapter, I did mention about this strain hardening process. Okay, here you can see this is the roller. Why we said that from this rolling process it will harden the metal. If you still remember the knowledge from the second part of this chapter, in order for metal to be deformed, in order for metal to be deformed, the dislocation line need to be moved to the other location when we apply a force onto the sample. Okay, but from this cold rolling process, when the sample go through these two rollers, it will produce a force of dislocation. Okay, you can see the density of the dislocation is increasing. Lots of dislocation in the metal after the metal go through the rollers. Okay, so for a sample, which having a high density of dislocation, when we apply a force onto the metal, this dislocation line, in order to deform the metal, the dislocation need to move from one place to another place. But when the sample have a high density of dislocation, when we apply a force, we give force onto the sample, the movement of this dislocation is blocked by other dislocation. So it cannot be deformed. And the metal become hardened. Okay. Okay. How about the hot rolling? Hot rolling, is performed at very high temperatures. Above 1700 degrees C for steel, which is above the recrystallization temperature for most steels. Because during the corroding process, the recrystallization process is occur. So this makes the steel easier to form, and resulting in products that are easier to work with. Okay, but due to the high temperature, rapid oxidation or layer or scale formation will be formed on the metal surface, which leads to the poor surface finish. Okay, and here this illustration is about the changes in microstructure of the metal during the hot rolling process. Okay, initially, these are the shape of the old grain structure. When it go through the rollers, this old grain structure will be elongated. And because of the heat, recrystallization will be occurs, and it will form new crystal or new grains. Okay. Okay, let's move to extrusion. Extrusion is a process where a bar of metal is forced through a die orifice by a compressive force that is applied to a ram. Okay, the extruded piece has the desired shape and a reduced cross-sectional area. For this extrusion process, we need to have a container in order to put the metal billet, and then we need to have a ram and also die, which has the shape of the final product. Okay, during this process, the compressive force, force, is applied to this ram. This ram will push the billet and force the billet to go through the die. Okay, to go through the die. This is what we call as a extrusion process. For a product which having a hollow shape, for example, for a pipe, this mandrel, ram, this ram need to have this kind of shape so that it will produce a hollow area or hollow shape in the final product. This one is for solid product. Solid, and the bottom picture is for hollow shape product. You can see from the animation here. Okay, this is metal block. This is RAM. And this is the die. This is the end product. End product. Okay. Okay. So these are examples of extruded products. Extruded products with hollow cavities. Hollow cavities. Okay, for this extrusion, it's normally used for metal which difficult to form. For example, stainless steel, nickel-based alloys, and other high temperature materials. Okay, let's move to the last technique under the forming metal process. Okay, drawing. Drawing is the pulling of a metal through a die which having a tapered bore by means a tensile force is applied onto the exit side. Okay, you can see here for this drawing process, the machine need to have a die. Okay, the hot roll coil will go through this die. Will pull by the tensile force which is applied on the exit side of the machine. Okay, please I hope you can compare between extrusion, the process which we learned in the previous slide, extrusion, and also this process, drawing. For this extrusion, we need to have a metal bar. Then we need to have a die. Example, this is a die. For this extrusion, the compressive force is applied to the RAM. This is RAM. Compressive force is applied to the RAM. Compressive force. Where you can see here, the force is applied from the back of the metal. And this process will push the metal the metal will be forced to go through the die. For this drawing process, we need to have a metal and then die. For this drawing, the force is applied from this side, from the exit side. The force is tensile force. The force is applied from the front of the metal. For drawing, but for extrusion, the force is applied from the back of the metal in order to force the metal to go through the die. Okay. What are the common products for drawing? Common products are rod, wire, and tubing products. Okay, normally drawing start with a cold or hot rolled rod. Okay, the draw speeds vary about 30 to 300 feet per minute. Okay, the term wire refers to a small diameter products under 5, less than 5 mm. Okay, now we move to this casting process. Yeah. Casting process is a fabrication process, okay, whereby a totally molten metal is poured into a mold cavity, which having the desired shape. Okay, upon solidification, the metal assumes the shape of the mold, but on the same time will experience some shrinkage. There are 3 conditions where these casting techniques are needed. One is when the finished shape of the product is so large or complicated that any other method would be impractical. So, casting is the best method to be used. Okay. The second condition is when a particular alloy is so low in ductility, meaning that we cannot give any mechanical force okay, to the metal in order to deform or fabricate the product. Okay, and the third condition is because casting is the most economical, when compared to other fabrication processes. Okay, here you can see this is an example of casting products. This is engine block. Yeah, you can see the shape is complicated. Okay, which has a hollow shape, shape in the product. Okay, casting process involves 3 steps. 3 steps. Three steps. The first one is pouring the molten metal into a mold, which having the pattern of the end product. Okay, and then allow it to cool. Once solidified, we remove the metal from the mold. Okay, here you can see this is the molten metal, metal in liquid phase, poured to the mold. This is mold which having a cavity. Okay, and you can see from this short video, molten metal will flow into the mold and try to fill the region or the area in the mold. Okay, there are 3 important factors we need to consider during this casting process. One is the flow of the molten metal into the mold cavity. Second is the solidification and cooling of the metal in the mold. And the third one is the type, the influence of the type of mold material. These 3 factors will affect the properties of the casted product. Okay. Okay, let's move to this one. This is about the microstructure. microstructure of casted product. There are 3 distinct regions or zone. The first one is chill zone. Okay, where is the chill zone in this illustration? Okay, this is the side view of a metal, a solidified metal in a mold. Yeah. Okay, you can see here. This is mold, and this one inside the mold is the product or cast product. Metal, the metal, the solidified metal. Okay, for this, for the microstructure of the solidified metal, it can be divided into 3 zones. Okay, the first one is the chill zone. Chill zone is the zone just next to the mold. It occurs on the wall of the mold where the wall chills the material. This wall will first chill the grain. It will first chill the metal just next to it. Okay, meaning that here is the start of the nucleation of grains. Start of the nucleation phase during the solidification process. You can see on all next to the mold, you can see the sphere-like particle. This is nuclei of metal start to form. Okay, next, after this region or zone, we can see another different shape of microstructure. Here, this is columnar zone. Columnar zone. The grains grow towards the center. If you look at the grains is thin, long, and elongated. Okay, elongated. This grain is elongated and move toward the center. If you look at the grain, this grain is formed perpendicular. Okay, this is assume this is the mold wall. The grain is formed perpendicular. This is grain. This is mold wall. The grain is formed perpendicular to the casting surface. Perpendicular meaning that 90 degrees. Okay, to the casting surface. Okay, next, after this zone, at the middle here, this is equate zone, where the grains are spherical, randomly oriented crystal. Okay, so there are 3 zones formed in the casted product. Okay, under the casting process, there are few types. The first one is sand casting process. Why this process called as a sand casting process? Because the material for making the mold is made of sand. Why sand? Because sand can withstand high temperature, more than 1,600 degrees Celsius, and is inexpensive and easy to mold. Is inexpensive meaning that the mold, the sand, the sand can be recycled. Okay, the steps in sand metal casting start with placing a pattern which having the shape of the desired casting in sand to make an imprint. Yeah? So here for the sand casting process, we need to have this coat part and also the drag part. The yellow area here is actually the mold. Mold made from the sand. This is the mold. Okay. After we combine the two part of the mold, and then we have to do a gating system. We have to create the runner, the riser, and also gate in order for the metal to flow into the cavity in the mold. Okay, and then filling the resulting cavity with molten metal, allowing the metal to cool until it solidifies. And once solidified, we break the sand and remove the product. Okay. Okay, this animation shows you about the process. Okay, we have pattern here. The pattern is divided into two parts. And then we pour sand. Pouring sand, we use special tools to compact the sand so that it will leave the imprint of the pattern. Okay, and then we bring together the pattern, and then pour the molten metal. Okay, next is investment casting, or we call it as a lost wax, not wash, wax process. The pattern is actually made of wax, which is coated with a refractory material. What is refractory material? Refractory material is a material which can withstand a high temperature. Okay, and then this process is precision process, capable of casting of high accuracy product, low volume, complex shape can be made using this investment casting process. There are three stages of casting process. Okay. Okay, one is formation of the mold. Okay, and then wax is melted. And will produce a hollow cavity, and then molten metal is poured into the mold. Okay, this is an example of a product from investment casting. Okay. Okay, let's look at the step in detail. Okay, first, you start with a wax pattern. This is the pattern. This is the shape of the product that we want to produce, made of wax. Okay, why wax? Because during the process, we will melt this wax. So it will leave a hollow shape in the mold. Okay, second, several patterns are attached to a sprue. Okay, and then we attach all the patterns to a sprue. Okay, to form a pattern tree. And then the pattern tree is coated with a thin layer of refractory material. Coated in a refractory material. So it will form a full mold. So this is the full mold. Okay, to make it rigid. Okay, 5. The mold is held in an inverted position, and heat is applied in order to melt the wax, and it will leave a hollow shape. Okay, 5. the mold is inverted position, held in inverted position, and then we heat the mold, and the wax will be melted, and it will it will drip out of the cavity, and it will drip out of the cavity. Okay, and then says the mold is preheated to a high temperature to ensure that all contaminants are eliminated from the mold. Okay, and it also permits the liquid metal to flow easily into the cavity. Okay, the molten metal will flow into the cavity. Okay, once solidified, the mold is broken away. Once solidified, the mold is broken away, and the parts are separated from the sprue. So this is the final part. Okay. Okay, this is how in industries they do the coating process of the tree. You can see here. This is the pattern tree immersed into the refractory material in order to make a rigid mold. Okay, what is die casting? Die casting is a permanent mold casting process in which molten metal is injected to the mold cavity under high pressure. You see here this animation. Okay. Animation start with a molten metal and then push into the die. Once cooled, the product is ejected from the machine, from the mold. Okay. There are two ways of doing this die casting process. It can be performed under hot condition, where the metal is in the molten or liquid phase, or cold condition. Okay, using a metal billet. Okay, die casting process we produce high volume of products for alloys having low melting temperature. One of the example for this die casting process is a Hot Wheel car. The body of the Hot Wheel car. Okay, now we move to the powder metallurgy. Powder metallurgy is a process involve the compaction of powdered metal, followed by a heat treatment process to produce a dense piece of product. This method is suitable for metal having low ductilities and high melting temperatures. It begins with a mixing process, mixing of metal powders and additive. We mix these powders until it's homogeneous, and then we bring the mixture of the powder to the machine for the compaction process. Okay, for the compaction process. Okay, the product from this compaction process is called as a green product. Green product. Okay, then after that, this green product is heated to a high temperature. Is heated to a high temperature during the sintering process, so that the particles in the green product will coalesce. Will coalesce to form a solid component. Okay. Okay, this is the details explanation about the powder metallurgy processing. Okay, now we move to the welding process. In welding process, we join two or more metal together to form a single piece of product. Okay, when one part fabrication is expensive or inconvenient or impractical. Yeah? Both similar or dissimilar metals may be welded. During this process, we have two plates of metal, the metal to be joined, and the filler, this is filler material, are heated to a sufficiently high temperature to cause both metal plate to melt at certain area under this weld bit. Upon solidification, the filler material form a fusion joint between the work pieces. Okay, this is the fusion joint, or we call it as a weld metal. Weld metal. Here you can see two work pieces, work piece 1 and work piece 2. Is joined together using welding process. From the welding process, it will form a weld bit on these two work piece. Okay, because of the heat, because of the heating during the process, this process will produce a heat affected zone. Heat affected zone or HFF zone. Okay, this zone is the zone which is adjacent, adjacent to the weld bit. Okay, so this is the heat affected zone, which is metallurgically altered by the heat of welding. Metallurgically altered meaning that the microstructure changes during the welding process due to the heat. Okay, so this is the microstructure for the weld bit and also heat affected zone. This is the fusion zone or weld bit and heat affected zone. Okay, next to the heat affected zone is the unaffected metal. Okay, you can see here at the fusion zone, which is the weld bit, the strength is very high. Okay, and then the strength is decreasing due to the grain growth and also recrystallization process. You can see the changes of the microstructure. The changes of the microstructure, okay, will affect the properties of the strength. Okay, and then here this is unaffected base material. So when you check the strength on this area, you can see that the strength is actually the strength of the base metal, meaning that this area is the area of unaffected base metal. Okay. Okay, these are example of welding products. This is railway track. In order to combine, combine one metal piece with another metal piece, we need to have this welding process. Okay, same with this boiler. This boiler made of several metal plate. In order to combine, to join from one metal plate to another metal plate, we need to do welding process. So this is the welding bit, which was formed during the process. Okay, now we have come to the end of this chapter. Okay, so from this chapter 8, you have learned about the ferrous, alloys, the types of the ferrous alloys, and also the types of the non-ferrous alloys in the part 1 of this lecture. And then you also learn about the heat treatment process of steel in part 2 and the fabrication techniques in part 3. Okay, so thank you for watching and listening to my lecture, and all the best for this subject.